Bismillahirrahmanirrahim. Today we want to present about the group assignment for power electronics. The title is 3-phase inverter for NRL load. We are from a section 5 and the lecturer name is Prof. Madya Dr. Shamsul Aizam bin Zulkifli.
Next, before we start, I will introduce my group members. Our group members consist of 4 members. First one is Muhammad Irfan MOHD with metric number CE210186. Second is Ajmal Danish bin Muhammad ZEMRI with metric number CE210217. Third is Muhammad NIZAM bin ZAHARI with metric number CE210005. And lastly is Muhammad MUSTAQIM bin Muhammad SHUHAIMI with metric number CE210188.
Bismillahirrahmanirrahim. Assalamualaikum. My name is Ajmal Danish bin Muhammad ZEMRI and my matrix number card is CE210217. Now, I would like to present about the introductions. Okay, firstly, this project is to solve the issue or problem occurrences by develop a simulation model of a 3-phase inverter for NRL load by using a MATLAB software. The second, 3-phase inverter operating concept is that its constant 3-phase inverter switch, each of which may be linked to a load terminal. And third, the function of the 3-phase inverter is to change the DC voltage to 3-phase AC supply. And next is in power system, uninterrupted power supplies, the 3-phase DC to AC voltage source inverter are widely employed in motor drive active filter in unified power flow controller. And the lastly for the introduction is pulse width modulation PWM, power supply that produce AC voltage and frequency with variable magnitude.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Irfan MOHD and my metric number is CE210186. Okay, today I will explain about the methodology. Okay, from the figure 3.1 shows the whole process for the successfully complete this project. So for the first step is to construct the model. Students need to brainstorming ideas by doing primary research about the project and the question given. Secondly, in this project, use that can be related to the 3-phase inverter of the RL load. Through the data given that consists of input voltage up, line-to-line voltage, frequency, and others. The value of the harmonic distortion can be calculated manually and must be less than 7%. So for the next process is by determine the switching schemes such as SPWM, TPWM, or modified PWM. Thus, in this project is our group using SPWM because of several advantages to using the SPWMs, which is suitable for all type of application. Low harmonic contents in the output voltage and air current, especially in the low frequency region. Then, using the MATLAB software, process is to create the Simulink model. So Simulink is offer a graphical platform that is interactive for modeling, simulating, and analyzing the dynamic system. In this process, each of the component is selected from the MATLAB library browser, such as IGBT, scope, voltage, measurement, and others. So after selecting all the components that are used, the components are connected to each other to create a circuit. Finally, after all the components connected, run the circuit until it is successful and remove the error and printing the result. That's all for the methodology. Thank you.
My name is Muhammad Nizam bin ZAHARI. My matrix number is CE210005. Today I want to explain about the simulation. For this circuit, we not adding the filter, and for this circuit, we adding the filter to get the THD lower than 7%. Okay. For this inductor, we set to 200 millihenry, and for capacitor we set to 480 microfarad. Then we set the DC voltage to 3 to 5.27, and for the result voltage output, we get the line 1, line 2, and line 3. And for waveform for current, output for current, for line 1, line 2, and line 3. Then we go to continuous, and we go to tools and FFT analysis for THD. Okay. Then we go to voltage first, then we for line 1, and we set time to 0.2 and number of cycle to 3, and for frequency we set to 50 Hz, and output, and we get the THD lower than 7%. And for input 2, line 2, we set lower than 7%. And for input 3, for line 3, we get the lower than 7%. And for the current, we get the input 1 for line 1, then we get the lower than 7%. And for input 2, we get the lower than 7%. And for input 3, for line 3, lower than 7%. Okay, that's all from me. Thank you.
My name is MOHD ZAHARI. Nomenclature is CE210005. I explain about calculation analysis. For first, from the data given, Vs equal to 1000 VDC and resistor is 14 ohm. Inductor equal to 0.3 millihenry and V line to line is 415 and frequency is 50 Hz. The output fundamental, we get the 900 VRMS, and then VO equal to Vs equal to 1000 VRMS. Then we get the Pout equal to 71428.6 and peak current is 35.72. Next, we get the THD equal to 48%. For calculation, we need the THD must less than 7%. After that, we calculate the distortion factor and get the DF equal to 34.22. Then, when we get the result for the new THD is equal to 3.8%, that's the Pout is 71428.6 watt. Then we get the calculation for VO1, 3, 5, and 7, and 9. We also need to calculate the Z1, Z3, Z5, Z7, and Z9. After that, we need to put in table, and the total power absorbed is 68478.7. Then for previous calculation, we get the 71428 for this frequency spectrum for this system. And lastly, for filter calculation, we need to convert 48% to less than 7%. Then we choose for inductor 220 millihenry, and for capacitor is 540 microfarad. And for FC, we get 14.60 Hz. That's all for calculation.
Assalamualaikum, and my name is MUSTAQIM bin SHUHAIMI, and my metric number is CE210188. Okay, I will discuss about result and discussion. Okay, and this is our design for our inverter. The component used are MOSFET, SPWM generator, capacitor and inductor act as a filter, and resistor and inductor as a load. Okay, for part A, for the circuit, it was designed to act as a generator for sinusoidal pulse with modulation. This technique is used to obtain sinusoidal waveform with the help of switching circuit to reproduce a sine wave by generating one or more square pulse of the voltage per half cycle. The part B, 6 pulse by using MOSFET. It is obtained by connecting the 3 pulse inverter in series on the DC side and in parallel on the AC side. With the help of this configuration, the current then can be changed from DC to AC, but the output waveform produced are not a smooth sinusoidal waveform. And for part C, it is a filter. It used to eliminate the various interference issue brought on by the inverter side harmonics. This part is part D. The load part, it can be R load or R plus L load or R plus L plus C load. Okay, for the next part is before adding filter to the inverter circuit. Okay, as you can see here, this is the inverter circuit without the filter. Okay, it shows that what the waveform created by the 6 pulse using MOSFET is not smooth like the sinusoidal waveform. As a result, our design can generate an AC signal, but it does so with a greater THD. As you can see in the right here, this is our THD, which is 62.29%. Okay, so the THD percent must be less than 5% of the AC source. The higher signal's harmonic must not exceed 3% for the fundamental voltage. The lower the THD percentage is, the better the output will be. So our inverter design is incomplete and does not meet the inverter criteria without a filter. Okay, next, after adding a filter to our inverter design. Okay, as you can see here, this is our inverter design with a filter and our THD and our waveform. The output waveform generated by the 6 pulse using a MOSFET is smoother, more resemblant of a sinusoidal waveform after filtering was added to the inverter design. The output THD is shown to have sharp decline from a line A, going from 62.29% to 3.18%. Because of that, the criteria has met. The THD must be less than 5% in order to design the inverter. It demonstrates how crucial filters are to achieve the intended result in our design. That's all from me. Thank you.
I would like to present about the conclusions for these projects. Okay, we can conclude that we are able to solve an open-ended problem by completing this project, which is to create a simulation model of a 3-phase inverter for NRL load. Identify the connection between the information required for a 3-phase inverter system and the issue. Next, the block diagram in Simulink maybe we use to apply the knowledge of a 3-phase inverter theory. The fact that SPWM in a 3-phase inverter is appropriate for all kinds of application is one of its benefits. Okay, for the finally, we are able to resolve the problem, the fact that this system total harmonic distortion THD value for both voltage and current is less than 7% is final step to accomplish the result of this project. Okay, that's all from me. Thank you.